All right, let's take a little look-see and see what happens when we have to deal with double and triple bonds. So we are going to go ahead and take a look at diatomic molecule nitrogen. So nitrogen is going to be N2. So I am going to draw an N and an N and figure out how many total electrons I have. They both bring 5. So I've got a total of 10 valence electrons that I'm dealing with. So I know I've got to bond them together. So there's 1, 2, and I'm going to satisfy my central. So 1, 2, or I've got 1, 2, 3, 4, 5, 6, 7, 8. So now this nitrogen's happy. I've used 8 electrons, so I've only got 2 left. So now I'm going to try to satisfy my peripheral. So I've got 1, 2, 3, 4, and I've used up all of the electrons that I have. Okay, so now what do I do if I run out of electrons? Well, what I can do is I can swing these electrons in to make what's called a double bond. So when I swing those in, I'm going to go ahead and erase those, and I'm going to draw my double bond. Okay, so now this nitrogen here has 1, 2, 3, 4, 5, 6, 7, 8. He's still happy. This nitrogen has 1, 2, 3, 4, 5, 6. So he is not happy. So I'm going to take these electrons now and swing them on in here to form what's called a triple bond. So now I'm going to get rid of these again. Okay, and I'm going to draw a triple bond. So now I've got 1, 2, 3, 4, 5, 6, 7, 8. He's happy. 1, 2, 3, 4, 5, 6, 7, 8. That nitrogen's happy. We're all happy. And now I can write in my ABX structure. So I've got one central atom for A. I've got one peripheral, which is B. And I've got one set of, or one unshared pair of electrons, which is X. So this is just a ABX formula. Okay, let's look at carbon dioxide. So my central atom's carbon. I've got two peripherals of oxygen. Carbon brings 4. Each oxygen brings 6. So 6 times 2 is 12. So I've got 16 total electrons to play with. So I'm going to satisfy my central. 1, 2, 3, 4, 5, 6, 7, 8. He's happy. Okay. Now I've got 8 more electrons to play with, and I think you've probably already noticed that I'm not going to be able to satisfy both of these. So what I want to do is I want to distribute these oxygens evenly. Okay, so I'm going to distribute 1, 2, 3, 4 to this side, and 1, 2, 3, 4 to this side. So now nobody's happy except for carbon. Okay, carbon's got 8. This oxygen has 6. This oxygen has 6. So what I'm going to do is I'm going to swing these in here to make a double bond, and I'm going to swing these in here to make a double bond. So now I'm going to erase those. Okay, and I'm going to draw in my double bond. Boom, 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 and there she is. Okay, so now my central, I've got 1. My peripherals, I've got 2. And I have no unshared pairs on the central. So that is my final ABX structure. Okay, so let's keep on moving. Let's see some situations that are going to violate the octet rule. And what violating the octet rule means is that we've got more electrons than, or we've got more things that we need to put on the central. So let's look at BRF5. With BRF5, I need to choose the central. How about bromine? Okay, because I've only got 1. I've got 5 fluorines. Okay, so let's put all 5 of those around him. 1, 2, 3, 4, and 5. Okay, so now bromine brings 7. All 5 of these fluorines bring a total of 35 because fluorines in group 17, 7 times 5 is 35. Add that up, I've got 42 electrons to play with. So first, I'm going to satisfy my central. 1, 2, 3, 4, 5, 6, 7, 8. Bromine's happy. Okay, I've used 8 electrons. 42 minus 8 is 34. So I've got 34 more electrons to play with my peripherals. Okay, so I'm going to now satisfy my peripherals. So I've got 1, 2. Remember, these bonds mean that this is the bond means that this is already sharing 2 electrons with bromine. So I've got 1, 2. So this is, I only need 6 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then this is still a peripheral, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so I've used 32 electrons. Everybody's happy. I've still got 2 more electrons to play with, and this guy's not even attached, okay? So what I'm going to do is now this needs an expanded octet. So what I'm going to do is I'm going to erase 2 of these electrons here. I'm going to actually make a bond with that, okay? So now he's actually going to be bonded to bromine. So now bromine has 10 electrons on the central atom. Well, I've still got 2 more electrons. What do I do with them? You always throw your extra electrons on the central atom. And so now this would be your Lewis dot structure. So now this is A, B5. How many unshared pairs on the central? 1. So AB5X would be the appropriate Lewis dot. I mean ABX structure. Okay, let's look at one more of these. Let's do ClF3. So I've got chlorine with 3 fluorines surrounding. Okay, chlorine brings 7. All 3 fluorines bring 21. I've got 28 total electrons to play with. Satisfied chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Okay, chlorine is now happy, and I've got 20 electrons left over. So now I need to satisfy my peripherals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What do I do with my last 2 electrons? Chunk them on the central. Okay, and now I've got A, B3, X2. Okay, that's the idea. If you've got more electrons, toss them on the central atom. Okay, now let's talk about resonance structures. Sometimes you can have more. Well, let's just look at carbonate. Okay, this is the carbonate Lewis dot structure. If you were to go back and do the carbonate Lewis dot structure on your own, this is what it's going to look like. Now, you've got carbon with 3 oxygens around it. Okay, now there's no reason that we had to put the double bond right here. The double bond could have just as easily gone right here, or it could have just as easily gone right here. Okay, so that's called a resonance structure. And so instead of drawing all 3 structures, we can show a resonance structure with this right here. And this is going to show us, when we put the dotted lines in between each one of these, that means that there's 1 double bond, and it could be with any oxygen at any given time. Okay, that's what a resonance structure is. So we're going to look at some of this stuff in class. What I want to do right now is I want to draw one last Lewis dot structure for us, and that is when you have an ionic compound that contains polyatomic ions. Okay, so let's look at sodium sulfate. With sodium sulfate, I've got sodium, which is a +1 ion, and I've got sulfate, which is a -2 polyatomic ion, meaning that I'm going to have 1 sulfate. I'm going to have 1 of these. Oh, I'm going to have 1 of these, and I'm going to have 2 of these. So what I need to do now is I need to draw my Lewis dot structure. For ionic compounds, I've got to use brackets. Okay, brackets and charges. So I'm going to put a sodium here. Na+. There's 1. And I'm going to put a sodium over here. Na+. And that means that I need to put my sulfate in between. Now you see I've left a lot of room. That's because I have to now, I can't just write SO4 right here. SO4 is a covalent compound. Okay, it's a polyatomic ion, but it's covalent in its own nature. So if I were to make SO4 2-, remember there's a 2- there, which is important. What I'm going to do is I've got to make my Lewis dot structure. So I'm going to choose the central atom. So I've got sulfur as my central. I've got oxygens around it. Boom, 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 boom. Okay. I need to know how many electrons are at the party. So sulfur's in group 16. So are all these oxygens. So I've got 6 times 5. So I've got 30 total electrons to play with here. But I've got to remember sulfate is a polyatomic ion. It's got a -2 charge. So I also need to add in electrons for the 2- because there's 2 extra electrons here. So I've got 32 total electrons. So now I need to satisfy my central. How about 1, 2, 3, 4, 5, 6, 7, 8. Sulfur's happy. 32 minus 8 is 24. I've got 24 electrons left to play with. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We got so lucky. Now I'm going to put this bad boy into brackets, put its charge on it, and hallelujah, we got it. Okay, so that's it, my friends. That's how we draw Lewis dot structures for all of our different covalent compounds. So next video, we're going to take a look at what all of those ABX structures mean. We got a lot of practice to do next class, so yeah.